Welcome to the Crazy Hat Chemist. So another video here on Kinetics. Bam! So today we're talking about interpreting rate laws. Okay, so here is a rate law or a rate equation. Okay, let us review that just a little bit. R is for the rate, K is for the rate constant, and then we have concentration of A, B, and C in the brackets there. And then the M, N, and P are the rate orders. Okay, so hopefully you got that. So the total reaction order is the sum of the exponents. So if we wanted to get the total order of this reaction, it would be M plus N plus P. All right, so let's do some specific examples here. If M were 1, then the reaction is first order with respect to A, yielding a rate law of R is equal to K times the concentration of A to the first power, because it is a M of 1. So it's a first order with respect to A. So here's the key part here. So you need to pay attention to this because we're going to be using this information to determine the rate equation or the rate law with experimental data. So therefore, if A doubles, then the rate goes up by a factor of 2. That's correct. Okay, so if the rate doubles and it goes up by a factor of 2, then you know that the reaction is first order. Okay, if M is 2, then the reaction is second order with respect to A. And let's find out what that rate law is equal to. Here's that rate law. That is R is equal to K times the concentration of A to the power of 2, because it's second order. Okay, all right, so here's the key part here. Therefore, if A doubles, then the rate goes up by a factor of 4. That's correct. Okay. All right. So now, hopefully you can get the reverse of this. And here is the reverse. If A is reduced by a factor of 2, then the rate will be reduced by 1/4. So hopefully that makes sense as well, because you're going to be using that as well to determine rate laws and the rate equation overall. Okay, if M is 0, then the reaction is 0 order with respect to A, yielding a rate law of R is equal to K times the concentration of A to the 0 power. Okay, so what does that mean? Therefore, if A doubles, then the rate goes up by a factor of 1. Think about that. That means that there is no change and the reaction is independent of concentration. Now remember, these orders, the rate order, can be fractional numbers, they can be negative numbers, but really here in this unit of chemistry, in this unit of kinetics, we will only be talking about 3 different possibilities. That would be 0 order, first order, and second order. Those will be our key ones. You need to review this slide so that you understand the concept between the first order, the second order, and the 0 order, and if I double something or even triple something, what the rate goes up by a factor of. Okay? All right. I am the Crazy Hat Chemist, and I got a cool set of crazy hats here that I'm going to be wearing here for you today. And it's a combination of 2. All right, you like that? Okay. Okay, if you like that, give me a thumbs up, subscribe to my YouTube channel, and only you can prevent forest fires.